All right. Good evening, everyone.
Good evening, sir.
So,
Good evening. All right. Let's do a couple of problems. There are good problems we have got now. There is no FIPC students here, right? It's only MPC. So there's a block on block. One block is 100 Newton weight, and the other block is weight 250 Newton. kg block, sorry, 10 kg block like this, and a 25 kg block like this. The force F is applied. Coefficient of friction between the surfaces is 0.4, and this surface is smooth. All right, ground is smooth. So friction between the 25 kg block and the surface is zero, but there is friction between 10 kg block and 25 kg block, which is coefficient of friction is 0.4. All right. When F is equal to 30 Newton, I have to determine the acceleration of the block. So what do I do? If I replace this with 30 Newton, what's the combined acceleration if at all they move together? The combined acceleration would be common acceleration is AC is equal to 30 by 35, which is nothing but 6 by 7 meters per second square. That's a common acceleration. But then I have to check whether, see, the only force on the lower block is friction due to the upper block, and acceleration is towards right. So force of friction has to be towards right because that's the only force, that's the only cause which is producing the effect of acceleration. Effect is towards right, so cause should also be towards right. So friction on this lower block should be towards right. Friction on the upper block is towards left. Alright?
Sir, can you explain once again?
Yeah. See, I've got a lower block means opposite force in the friction force. If I see the FPD, I've got normal reaction, mg, 25g. For horizontal direction, there is only one force which is possible that can produce acceleration which is horizontal. Horizontal acceleration A not today. There is only one force which is responsible for this acceleration, which is friction. So friction has to be towards right. Alright. Children, friction, why is it towards right? Because acceleration is towards right, and only possible force on this block is friction. So friction is the cause for this acceleration. Effect came out towards right, and this cause should also be towards right. That is why friction is towards right. Is it okay?
Yes, sir.
Now, friction will be equal to mass times acceleration. Acceleration is 6 by 7 and mass is 25. So that would be 25 into 6 by 7. But what is the limiting friction between the blocks? Mu times 10g. Because 10g is a normal reaction on the upper block. And which is mu times 10g. Limiting friction is mu times 10g, it's 10g, which is 100, that is 40 Newton. So limiting
yes,
friction is 40 Newton, but required friction is how much? 6 by 7 times 25. How much is this roughly? 25 into 6 is how much? 7. How
150
much
by
is,
7, sir.
yeah, 150 by 7. How much is 150 by 7 roughly? 20 point something, right?
Yes, sir.
So which is less than limiting. So my limiting friction is greater than required friction. So my friction between the surfaces is sufficient enough to provide this acceleration 6 by 7. So they'll move together with an acceleration 6 by 7. So when F is 30, they'll move together with an acceleration 6 by 7 together. But what is the limiting force at which they will separate? they will separate when friction between the surfaces reaches limiting friction. Limiting friction reach అయినప్పుడు friction cannot further increase, friction cannot further adjust. Oh, just a second, Bhavna. Spotlight పెడతాను and this will. It's fine now, right? Now next force applied is 250 Newton. If force is 250 Newton, in that case, what's the common acceleration if at all they move together? 250 by 35.
$50/7, sir. Sir, we can't hear you. You're not audible.
Yeah, am I audible now?
Yes, sir.
Yes, all right. Sir. Yeah, thank you. All right. So lower block, if at all they move with common acceleration, this would be the common acceleration. But I have to check whether my friction is sufficient enough to produce this acceleration. So how much will that be? Friction required would be F is equal to 50 by 7 into 25. So this would be 1250 by 7, which is 50 by 7 into 25 is how much?
$181 point.
All right. So that's greater than 40. But my limiting friction is 40. I cannot supply friction which is more than 40. But required is 180. That means my friction is not sufficient enough to produce that acceleration. So they will separate. So they are not going to move with common acceleration, but they'll separate. So they'll separate ante, with what acceleration will they move now? Separately ante, I'll write the physical domain separately for both the blocks. So 40 by 25 is acceleration of 25 kg block. All right, that is how much? 5 8s, 5 5s. That is 3.6 meters per second square. And acceleration of the upper block would be 10 kg block would be 250 minus 40 divided by 10. That is how much? 210, 21 meter per second square, if I'm not wrong. Yeah.
Sir,
So lower block moves with a very less acceleration, 3.6. Upper block moves with an acceleration 21 meter per second square.
6 na, sir.
Sorry?
Sir, by 5 is 1.6.
Oh, 1.6. Sorry. Yeah. All right. Thank you. All right. So this is going with very small acceleration of 1.6. Whereas this goes to an acceleration. Is this correct? Is this correct, Bhavna? 250 minus 40 by 10 is 21.
Yes, sir.
All right. All right. So acceleration of the upper block is 21. Lower block is 1.6. Look at this. Lower block is going with an acceleration of this one because limiting friction on that is 40. Between the surfaces is 40. And force on this lower block cannot exceed 40. 40 by 25 is the acceleration of the lower block. Whereas 250 minus 40 by 10 is the acceleration of the upper block. All right. ఓకే. సి బ్లాక్ ఆన్ బ్లాక్ మీరు విన్నారా? రికార్డెడ్ సెషన్ విన్నారా? Otherwise, it becomes really difficult for you to crack the problem on block. Alright, simple strategies ఉన్నాయి block on block కి. Okay, let's look at another inclined plane problem. $60 kg block and 20 kg block. This angle is 30 degrees. Alright, I have to determine the acceleration of the blocks. So what I first do is I'll first presume it's frictionless. Frictionless అనుకుంటే, alright, let's do one thing. Let's first do ఇది పుల్లి లేకుండా చేద్దాం. ఇలా స్ట్రిప్ పెట్టాం. 20 kg block. So this is 60G sine 30. So that will be 30G. And this is 20G. So this supporting, opposing. So this will go downward, this will go upward. If there is friction, friction will be acting upward. Because it has a tendency to slip downward, friction acts upwards, and this will go upward. Alright? ఎలా చెప్పాను? 60G downward. Component of 60G, I take component down the inclined plane, perpendicular to inclined plane. Perpendicular to inclined plane ఎంత ఉంటుంది? 30 root 3G. So normal reaction is nothing but 30 root 3G. So limiting friction is mu times 30 root 3G. That's the limiting friction or kinetic friction. So I have to determine whether the blocks will move or not. If it is frictionless, this will tend towards downward and friction will act upward. But friction will self-adjust so as to counterbalance the net external force. Net external force ఎంత ఉంది ఇప్పుడు? 10G ఉంది. 30G minus 20G. 10G. That 10G is less than 30 root 3, mu times 30 root 3G. mu ఎంత ఇచ్చారు? I'll tell you mu, right? Mu is 0.25. So 1/4 of 30 root 3G. So 1/4 of 30 root 3G, that is 300 root 3. 1/4 of 300 is 12 root 3. And this is 10G. 12 root 3 is greater than students, just tell me whether this is greater than or less than 10G. 100. And this is 120 root 3. Sorry, 12 root 3, right? 300/4 is how much?
75, sir.
Okay.
Yes, sir. 75.
And 75 root 3 ఎంత ఉంటుంది? Is it greater than 100 or less than 100?
Sir, it is less than 100, sir.
Okay, that is why block slips down. Slowly. That's why block slides down. It has a tendency to slip down. Friction will be upward, but because this friction is greater than this friction, it will slide down. Limiting friction is less than the external force. Limiting friction is less than the external force applied. So it cannot self-adjust anymore. So sorry.
75 root 3, huh?
75 root 3. Is it less than 100 or more than 100?
75 root 3, 128, 129 ఉండొచ్చు, sir. Approximately.
Let's check. 3 కదా. Seven, 1.7975. So that would be someplace 5. Yeah, 128. So blocks don't move. Let me check the answer. God, thank. It means it's seventh one. Oh, page number 2. Yeah, block doesn't move. Right. Because static friction is sufficient enough to counterbalance the external force. Friction will be equal to 100 G and the blocks don't move. So 300 కింద ఉంటుంది, 20 కింద ఉంటుంది, and 100 is the friction. And the blocks don't move. So that's the answer. Blocks don't move. But then, if the friction is, what should be the value of friction for the blocks to start moving? అయితే ఎలా చేస్తాను? My mu n should be less than 100 G. So mu should be less than G gets cancelled out. So 1 by 3 root 3. So mu should be less than 1 by root 3. If mu is less than 1 by root 3, then blocks will tend to move downward, and that to downward. Why is it downward? Because here supporting force is greater than the opposing force. 30 G is greater than 20 G. So it will start moving downward. So minimum friction, maximum friction for which it can move, system can move is 1 by root 3. So if the coefficient of friction is less than 1 by root 3, it will definitely move. The blocks will definitely move and they'll move downward. Alright. Okay, next question is, there's a chain. This x is equal to 0. There's a chain here or rope where this part is rough and this part is smooth. Initially, we have seen there is a rod. I give it a velocity v0. I have to check whether the rod will enter the smooth surface or rough surface or not. Right? We have seen that in the last class. But now it's a rope. It's being pulled with that force F. Now to determine the velocity when it completely enters the smooth surface, length of the rope is L. I have to determine the velocity when the rope enters the smooth surface, completely enters the smooth surface. And this endpoint should come over here, and this endpoint will reach at distance L. Alright, so now there is variable acceleration. Why is it a variable acceleration problem? This force is constant, but the friction on this is towards left, which is mu times n, and n is equal to mxg, where mass is going on varying. Mass on the rough surface is going on varying, so normal reaction will go on varying, because of which kinetic friction will vary. So kinetic friction will be, net force would be F minus mu mxg should be equal to total mass into acceleration. Now this acceleration I'll write it as v dv by dx. Alright, now density of this, so net force on this is, let's say some F naught. Now he has given F naught is greater than mu mg. Alright, it's greater than mg or greater than or equal to mg. So that means it's initially it's equal to mu naught mg, mu mg. So it just tends to start Once it tends to start, it enters the smooth surface. So friction will drop, then it will lesser than mu mg, it will start accelerating towards right. So it's accelerating with a variable acceleration. So I'll have mu mg minus mu mxg. But what is mx here? Lambda times. What is the mass of this length? This is L minus x, right? Mu times L minus x times m by L times g. And this would be mu times lambda or m by L times Lg. Right? I'm writing in terms of m by L because m should get cancelled out. So m v dv by dx. M gets cancelled out. So mu g times L gets cancelled out. 1 minus L naught minus x by L. So 1 minus 1 plus x by L. So 1 get cancelled out, I'll get x by L is equal to A, which is v dv by dx. So I'll have A is equal to, which is v dv by dx, is equal to mu xg. You will understand this? All I did was simple equation. I've written this equation and he has given f is equal to mu mg. So I've written f as mu mg and I've written mu mxg, which is the variable force here. And the friction varying. Why is friction varying? Because mass on this rough surface is varying. And how is it varying? If x enters into this, L minus x is this. For whole of length L, mass is m. For length L minus x, mass would be L minus x into m by L. So mu mg is my normal reaction. Mg is my normal reaction. So mu into n is my frictional force, which is varying. Because this is varying, my acceleration is varying. I'll now integrate. P dv is equal to mu gx dx. I integrate it. When it is 0, velocity is 0. When it is L naught, velocity is v naught. So v naught square by 2 is equal to mu g x square by 2 from limit 0 to L, from limit 0 to v naught. So I'll have v naught, 2 gets cancelled out. V naught is equal to where is rho? Okay, rho is getting cancelled out. Rho is getting cancelled out. V square by 2, v square by fine, that's fine. So mu g times L naught is my velocity. Let me check the answer. Till then, you think is the procedure and the method understandable? Have you understood the method? Yeah, that's it. But he has said it is little greater than mu mg, right? Or the surface, this is little extended towards the right. So frictional force will be less than the applied force. So it'll start moving towards right. Alright. So we have considered a case where x is tending to 0, but it's not equal to 0. Alright. Otherwise, you can also do one thing. You can complicate this problem a bit. Well, this is fine, but you can complicate this problem a bit. We can write in terms of f naught itself. And write the whole procedure, get the whole answer in terms of f naught and substitute f naught at the end. Alright, f naught ఇవ్వలేదు అనుకుందాము, but f naught is greater than limiting friction. So if f naught is greater than limiting friction, this rope will definitely move towards right. Once it enters into smooth region, even a little part of the rope enters into the smooth region, applied force will be definitely greater than the limiting force, limiting friction. So it will definitely move towards, accelerate towards right, with some acceleration, which is very, very well acceleration. So F naught minus mu mx sig is equal to mv dv by dx. Mu x is this much. So let this be F naught only. So this will be now m doesn't get cancelled now. I can write this as rho times L and this as rho. So I'll have F naught minus mu rho g times L naught minus x by rho naught L is my v dv by dx. All right. Now I'll integrate this now. Dx, integrating it, v dv, integrating it. When x is 0, velocity is 0. When x is x, velocity is v. But I directly want the answer. I don't want the function. I want value at when x is equal to L. So I'll write when x is equal to L naught, v is equal to v naught. Required v naught. I'll integrate this. Pi 2, v square by 2 is equal to, I'll integrate the right hand side, which is F naught L naught by rho L naught minus mu rho g by rho L into L naught minus x. I integrate this from 0 to L naught. Alright, you integrate, your v square would be 2 times of this, v is equal to root of this one. All you have to do is to integrate. This integral is easy. Integral x dx is x square by 2. Integral some constant to dx is constant times x. Alright, so I'll leave this integral for you as so joint. Okay, let's go for another problem. You have understood the problem, right? Initially, my force was sufficient enough, just sufficient for it to start moving. It was just greater than limiting friction, so it started moving. But next case, I gave you a general force, which is F naught, which is definitely greater than limiting friction, but it could be anything, any value greater than limiting friction. So I'll just write this general force equation of motion, and go further integrate. Then write A is equal to v dv by dx. Integrate it. I'll get v as a function of x. All right, is it okay? Okay, let's go for another one. Mass m, and I've got a L-shaped wedge like this. There's a mass m here, and this mass is also, let's say it's m, or m naught and m naught. This is a hanging mass which is m. I have to determine m, minimum value of m, such that it is smooth. Coefficient of friction between the surfaces is mu. This horizontal surface is smooth. The coefficient of surface between the block and the L-shaped wedge is mu. I have to determine the minimum value of m. Why is he asking minimum, you think? Minimum value of m such that this doesn't slip on the wedge, on the L-shaped wedge. Alright. So what do we do? It doesn't slip. It doesn't slip until see what is happening. Because of this, you'll have some acceleration A. This will have an acceleration A naught. If I stand on this one, I'll have a pseudo force on this one, MA naught. Normal reaction is this way. So mu n is this way. M naught g is this way. If m naught g is less than mu n, then the block will stay over there itself. So I'll get the relation between acceleration and g. How will I get that? M naught g should be less than mu times n. So mu times m naught into a naught. M naught gets cancelled out. So a naught should be greater than G by mu. I got the condition for acceleration such that it doesn't slip. Alright, I have just drawn the FBD of the block with respect to the reference accelerated reference frame. I can do it from ground frame or accelerated reference frame. I have chosen accelerated reference frame. Alright. So when I choose this, I'll have a pseudo force. Apart from all the real forces, which is N, mg, and friction, I'll have a pseudo force which is opposite to the direction of accelerated reference frame. Acceleration of the reference frame. Acceleration of the reference frame is towards right. Pseudo force on the block is towards left. Alright. Now I got condition for acceleration is A should be greater than G by K. If it is equal to G by K, it is tending to slip. It is just any perturbation, any disturbance will make it slip down. But it will make it come down with constant speed. But when A is greater than mu G, it is definitely stay there. Why? But because mu N is greater than mg. My limiting friction is greater than mg. So my limiting friction is greater than external force. My friction will self-adjust so as to counterbalance the external force. Alright, now let's get the acceleration. How will you get it? mg by m plus 2m, m naught, is my acceleration. My acceleration of the system of the blocks is this, right? Because normal reaction is an internal force. So mg is supporting force. There is no opposing force here. Mass mg by supporting force minus opposing force, which is 0, by total mass will give me acceleration of the blocks. Now this one should be greater than g by mu. So g gets cancelled out. M should be greater than m plus m naught 2m naught by k. Sorry, mu. So I'll have m should be greater than 2m naught by 1 minus mu. Let me check the answer. Is 1 minus mu? Yeah, yeah. Sorry. Look at this. E is greater than g by k. Yeah, that's right. But then when mu goes over here, mu mg minus mu m minus 1. Okay, this is mu minus 1, sorry. Alright, look at this. So this is the condition for m, minimum value of m. Because anything less than this, my acceleration will not be sufficient. I mean, acceleration will not be will be less. Pseudo force will be less. That means normal reaction will be less. Limiting friction will be less. Not sufficient enough to counterbalance the external force. If mass is more, my acceleration is more, pseudo force is more, normal reaction is more, limiting friction is more. Alright. And look at this. M is greater than 0, right? Mass is greater than 0. That means my mu has to be greater than 1. So for mu, anything mu is equal to 1 or less than 1, this block will definitely slip. So mu has to be greater than 1 and m has to be greater than this value. So this could be a multi-correct question also. He can ask you what's the minimum value of m and what is the minimum value of mu. Alright? Is the problem clear? You want me to repeat this? It's a good one.
Yes, sir.
Yes, sir.
Should I repeat?
Yes, sir.
Yes.
Alright. You please ask. Don't hesitate, okay? చూడు ఏమైతుంది ఇక్కడ అంటే మాస్ వల్ల యాక్సలరేషన్ వస్తుంది. యాక్సలరేషన్ వల్ల ఈ రిఫరెన్స్ ఫ్రేమ్ with respect to this reference frame, I've got a pseudo force on the block. Pseudo force is counterbalanced by normal reaction. So normal reaction is dependent on acceleration. Acceleration ఎక్కువ అయితే normal reaction ఎక్కువ అవుతుంది. Normal reaction ఎక్కువ అయితే limiting friction ఎక్కువ అవుతుంది. Limiting friction ఎక్కువ అయితే my self adjusting capacity will be more. External force ఎంత ఉంది? mg ఉంది. So that to be counterbalanced, my limiting friction ఎక్కువ ఉంటే I'll have the capacity to counterbalance mg. Limiting friction mg కంటే తక్కువ ఉంది అనుకోండి, it will slip down. So ultimately it's depending on this mass. Mass ఎక్కువ ఉంటే my chances of this not slipping is more. Mass తక్కువ ఉంటే chances slip అయ్యడానికి chances ఎక్కువ ఉన్నాయి.
Yes, sir.
Now, so how will I get it? Yeah, good. Now, how will I get that condition? My mg should be less than limiting friction,
Mu.
which is mu times mu ma. ఇది mu ma ఎందుకు ఉంది? mu into n is equal to ma ఇక్కడ. With respect to this reference frame, n is equal to ma కదా?
Yes, sir.
So m gets cancelled out. I'll get the condition g is less than mu into a naught. So a naught is greater than g by mu. So acceleration, minimum acceleration g by mu ఉండాలి. దానికంటే ఎక్కువ acceleration ఉంటేనే this block will have sufficient limiting friction so as to counterbalance mg. అయితే నాకు యాక్సలరేషన్ కండిషన్ వచ్చేసింది. ఇప్పుడు యాక్సలరేషన్ నేను ఎలా తెచ్చుకుంటాను? నెట్ ఫోర్స్ బై టోటల్ మాస్. నెట్ ఫోర్స్ ఎంత ఉంది? ఎక్స్టర్నల్ ఫోర్స్ mg ఉంది. mg is equal to m plus 2m naught. Why am I adding these two blocks together? Because they are moving as if they are one block. One block లాగానే మూవ్ అవుతున్నారు. ఇలా మూవ్ అవుతున్నారు. Alright, they are not separately moving. So their accelerations are same. That's why I can write this equation into a naught. ఇప్పుడు a naught ఏంటి ఇక్కడ? So a naught is equal to mg by m plus 2m naught. Now this is greater than g by mu. So g gets cancelled out. M is greater than m plus 2m by mu. Cross multiply, I'll have mu m minus m is greater than 2m naught. So I'll have 2m by mu minus 1 as my m. 2m naught by mu minus 1 is equal to m. I think m వచ్చింది. Now we know that mass is always mass is greater than 0. Greater than 0 until 2m is greater than 0, so mu should be greater than 1. That is one condition for them not to slip. The other condition is m should be greater than 2m naught by mu minus 1. So m should be mu should be greater than, yes.
ఇక్కడ 2m naught by nu -1 ఎలా వచ్చిందో చెప్పాలి కదా.
Okay. 2m naught plus m by k. All right.
Yes, sir.
Okay. Yes, ma'am. All right. I'm concluding. All right. So this is mu m ఇక్కడ వస్తుంది mu m minus m greater than 2m naught. So I take m common, mu minus 1 వస్తుంది times m greater than 2m naught. So m is greater than 2m naught by mu minus 1. Is it okay?
Yes, sir.
All right. So let's stop here. You'll have chemistry class now. All right. Thank you all. Students, keep practicing. Keep thinking about a problem. Keep one problem in your mind. All right. Only then you can think. Keep your thinking active. All right. Physics will not be overnight subject. You cannot do it overnight. Master cheyadaniki overnight lo raadu. I'm telling you again and again. All right. Excuse me, sir. Himanshu, sir.
Yes, good evening, sir.
Good evening, sir.
Everyone.
Yes, sir. You may please continue, sir.
Okay, sir. Good evening, everyone.
Good evening, sir.
Good
How are
evening.
you? Everything's fine? Yes. Are you guys fine?
Yes, sir.
Okay, great. So in the morning, we have discussed about certain things and hope you got the PDF. I've shared the PDF. Got that? Not yet. So we see, I've shared this PDF, whatever we have discussed in the organic, and right now I'll continue. I'll give you 4-5 examples of this thing. So just go through it. Later on, you will do by your own. We'll discuss in the next classes if you will not get any answer. Okay. So right now I'm continuing with the IUPAC, and let's start with the IUPAC of Easters. Okay. So in the morning, I've done 2 to 3 names of Easters. So I'm repeating it again. See what exactly the Easter is. That is R C double bond O single bond O single bond R. This is called Easter. So if I talk about the Easter, this particular group, this till O, is known as alkanoate, and this one is alkyl. This one is alkyl. For example, I'm doing a simple example of HC double bond O single bond O single bond CH3. So this is the compound. So I told you that half of the portion is considered as alkanoate and this one is alkyl. So first you'll do the naming of alkyl, then you go for the naming of alkanoate portion. What is alk? Alk is the number of carbon. Okay. So first, if I want to do the naming of alkyl portion, we have only one carbon over here. So for one carbon, we considered as meth. We name it as meth, and at the last we'll use YL, that is called methyl. In the rest portion, we have alkanoate. Alk, again, how many carbon is present in the alkanoate portion? Only one carbon is present. So for that one carbon, we'll use again meth. Then followed by noate. That is called methyl methanoate. Clear? Clear?
Yes, sir.
Okay, I'm giving another example. Second one, that is CH3, CH single bond, C double bond O single bond, CH2 single bond CH3. Now, okay, just make it easy first. CH3. Now, what is the name of this compound now? Speak fast. First, you'll do the alkyl portion. This one is the alkyl portion. This is alkanoate portion. See, alkyl will be the one which have lesser number of carbon atom. Okay, so I will do one more example. Before that, just tell me what is the name of this compound. On the alkyl portion, what we have? One carbon. So the name will be
Methyl.
methyl. And in the third alkanoate portion, we have 3 carbons. The name will be?
Prop.
Prop,
Yes,
sir.
propanoate.
Propanate.
Propanoate. The name will be methyl propanoate. Clear?
Yes, sir.
Yes, sir.
Okay, very good. Okay, let's take a third example. CS3, CH2, single bond, C double bond, O, single bond, O, single bond. Okay, I think we have done something wrong. Okay, one thing is wrong over here. One more O is there. Otherwise, it will be ketone. CH3, CH2, C double bond, O, single bond, O, single bond, CH, then CH3, CH3. Now, how you will do the name? Just think twice. I'll give you 2 minutes. Fast. Think. Just give it a try at least. See, you'll. What is the possibility? It will be wrong. Just give me 1 minute. It's not. Anyone? No one can name this.
Sir, is
Okay.
it propenyl propanate?
What?
Propenyl propanate.
Propenyl propanoate, a sort of correct answer, but see, this is called iso condition. When the main chain is this side and we have 3 carbon here. This is the main chain. Just imagine we have bonded a chain over here. So this condition is called iso condition. If you have learned isomerism in the lower classes, you'll see that this is an iso condition. So in this particular condition, what you do, the name of this particular compound will be iso. Since 3 carbon is there, it will be propyl. On the on this position we have 3 carbon. So isopropyl propanoate. Okay. So this will be the answer. Let's go for another one. Let's do the naming of anhydrides. What is the meaning of anhydrous condition? Anhydrous means powder, a sort of powder condition is there. So anhydrous, when powder condition is, it means the water molecule is eliminated. First, listen how anhydrides are formed. For example, I'm taking the example of CH3 C double bond or single bond OH. Okay, Bhavana, tell me the name of this particular compound. Or anyone else, just because I taught this particular compound in the morning. 2 carbon is there and carboxylic group is there. Anyone? What do you do for 2 carbons? What is the root word for 2 carbon?
Ethanoic acid, sir.
Ethanoic acid. Very good. So it's 2 carbons, it means ethane, and 1 oic acid. Just because COOH group is present. So I'm taking 2 molecule of CH3 COOH molecule and I'm eliminating what water molecule from there. So one water molecule when eliminated, the compound formed CH3 C double bond O single bond O single bond C double bond O single bond CH3. So from this molecule, when I eliminated this water molecule, there is an anhydrous condition is there. So this is known as anhydride. This is known as what? Anhydride. Since this particular compound is formed from ethanoic acid, so this is known as ethanoic anhydride. That's it. You write like this. Clear? So you'll use the parent name and then you'll write the anhydride at the last. That's it. So, okay, just see. CH3 C double bond O single bond OH. And another example is CH3 CH2 C double bond O single bond OH. This is called ethanoic acid. This is ethanoic acid. This is propanoic acid. What I'm doing, I'm eliminating a water molecule. It will form CH3 C double bond O single bond O single bond C double bond O single bond CH2 and then CH3. So this particular compound, this is an anhydrous condition. So this anhydrous condition is formed from which acids? Ethanoic acid and propanoic acid. Since it is formed of ethanoic acid and propanoic acid, the name of this compound will be from the parent chain. Parent parent atoms. So its name will be ethanoic, propanoic. Since it is made up of ethanoic and propanoic, so we'll write ethanoic, propanoic, and at last you'll write anhydride. That's it. Clear?
Yes, sir.
Okay. Tell me the name of this compound. CH3 C double bond O single bond OH, and then I'm writing CH3 CH2 CH2 C double bond O single bond OH. Again, water molecule I'm eliminating. It is forming a compound CH3 C double bond O single bond O single bond C double bond O single bond CH2 CH2 CH 1 2 3 4. Okay. Now, what will be the name of this compound? Alphabetic order. Just remember, this is 4 carbon, so it is known as butanoic acid. This is 2 carbon chain. This is known as ethanoic acid. Now what? What will be the name?
Butanoic, ethanoic, anhydride.
Very good. It will be
Ethanoic.
butanoic, ethanoic, anhydride. Why I write the name of this particular butanoic first?
Alphabetic order.
Alphabetic order.
Alphabetic order. Very good. So this is the way how you write the naming of anhydrides. Clear?
Yes, sir.
Okay. Let's move further for the acid chloride. Okay. So what is acid chloride? So RC double bond O single bond OH. This is carboxylic acid. This is carboxylic acid. I'm eliminating the OH and I'm adding a halogen. What is X? Chlorine, bromine, iodine you can take. But right now, I'm taking only Cl. In this case, we are adding Cl. So it will form RC double bond O single bond Cl. So RCOCl is known as acid chloride. This is known as what? Acid chloride. So how you will write the name? See, if alkane is present, alkanoic acid is present, then what you will do? You will write alkanoyl chloride. Am I audible?
Yes, sir.
See, if you're having any disturbance, then let me know, just because in our area it's quite heavy rainfall right now. Am I audible now?
Yeah, sir.
Yes,
Okay,
sir.
done. Okay. So if alkanoic acid is present, for example, ethanoic acid is present, so it will be ethanoyl chloride. Okay. If propanoic acid was there, and it will be propanoyl chloride. If butanoic, then butanoyl chloride. So example we can do CH3, CH2, C double bond O, single bond Cl. So first tell me one thing. Whomsoever is interested in telling, just do it first. Tell me from which acid this particular compound is made up. Just think twice. How many carbon are there and how many carbon, and then count the number. Which one? Fast. You are correct, I think.
So is it ethanoic acid?
No, 3 carbon are there, na?
Propanoic.
Propanoic acid. Very good. So this particular compound is made up of propanoic acid. So if I do the numbering, so if I write the name, so it will be considered as, since it was made up of propanoic acid, you will write propanoyl chloride. Clear?
Sir, can you tell me,
Yes.
so why do we write nol at the end?
See, the suffix we use for this particular compound is, see, in place of IC, that was in acid, we replace it by YL. Okay, so this is a way how we write the compound name of acid chloride. So from the parent chain, you have to change it into the acid chloride. So you have to name from the parent acid, then you'll write YL instead of IC. So this is the rule. Clear?
Yes, sir. Thank you, sir.
Okay, then tell me the name of this compound now. CS3, CH2, CH single bond, CH3, CH2, C double bond, O single bond, Cl. We'll do the numbering from the side from where the functional group is there. So COCl is the functional group right now. So we'll do the numbering from the right hand side. 1, 2, 3, 4, and 5. On the third position, we have a side chain. So it will be 3 methyl. Now tell me the name. 5 carbon. It is made up of which acid?
Pentanoic acid.
Pantanoic acid. So its name will be
Pentanol chloride.
Phenol chloride, sir.
yes. It will be pentanoyl chloride. Clear?
Yes, sir.
Yes, sir.
Yes,
Okay,
sir.
one more example. Let's take one more example. CS3, CH2, C double bond O. C double bond O. Okay, let's change something. Here Br, then Cl. Now tell me the name. Not here, Br. Just write Br here. Now tell me the name.
Three bromopropanoyl chloride, sir.
Very good. 3 bromo propanoyl chloride. Very nice. So it means now you can feel like IUPAC is not that much tough, I think. See, we have to go step by step. If we'll go step by step, it will be easy. If I'll say one thing that don't eat 3 times or 4 times and eat everything on a single time, either in the breakfast or in the lunch or else in the dinner. So you won't take. I think no one can eat that much at a particular time. So just take step by step. You'll learn IUPAC very easily. It's not that much tough. But you have to remember and practice. Next is amides. What is amide? Again, R C double bond O single bond OH. Replace OH by NH2 group. It will form RC double bond O single bond NH2. This is called amide. This is called amide. So, see, you can no one notice one thing that I'm making every compound from right now. I'm making every compound from the carboxylic acid. Is that true?
Yes,
No
sir.
one was noticing that I'm making every compound from the carboxylic acid. Since
Yes.
remember it right now that C double bond O is the parent group of all. It is a parent group of carboxylic acid. This is a parent group of anhydride. It is a parent group of esters. It is a parent group of amides, acid chloride. Okay, so just remember this is a parent group. So what do you have to remember in amides? Amides are basically of 3 types: 1 degree, 2 degree, and 3 degree. What is 1 degree amide? That is RC double bond O single bond NH2. This is called 1 degree amide. That is primary amine. Okay. Sorry, primary amides. Secondary amides are considered as RC double bond O single bond O. RC double bond O single bond NH, and along with the H, I'm removing one hydrogen. I'm adding R group, alkyl group. That is called secondary amine. While in amides, then third case R C double bond O, then N, R and R. This is called tertiary or 3-degree amine. So this is considered as primary. This is called secondary. This is called tertiary amide. Clear? This
Yes,
much?
sir.
Okay. Let's start with the primary amide. See, while doing organic, you must have your pen and pencil, one book, a notebook at least, so that whatever compound I'm making, just make it and just try it again. Right now, understand the fact, and later on, same compound, you have to do it again. This is what we call practice. Okay, clear? And first of all, let me tell you a simple story. Basic thing. You know what is egg? Egg is meant to be broken. It have two things, either internal or external. If you'll break it from outside, it will break and you'll eat it. But if it will break from inside, it will give to a newborn. Okay, so most of the people while doing that particular organic thing, they have a fear of organic, that when I'm doing the organic, I cannot do. It's very tough. It's a huge thing you have to remember. See, this is what we call internal factor of our brain. You need to break first. You need to break that particular thing from inside. That is a thing which is holding most of the people while doing the organic. But if you break it from outside, I'm doing the pressure that just learn, you'll not learn. Internally, you have to make a decision that I need to learn, I need to qualify the exam, and I have to do everything. I have to learn. So you have to make a schedule, and according to that, you have to learn it again and again. Why I'm saying this thing, why I'm giving you this kind of example, just because I'm feeling like most of the people are not revising. So this is the main factor. Okay. So just remember, the first you need to remove that fear. Primary amides. Okay. So primary amides, see how I'm writing the name. You have to replace oic acid with amide. Okay, so just take an example, CH3, CH single bond, CH3 single bond, CH2 single bond, COH. This name of the particular compound 1, 2, 3, 4. That is 3 methyl 4 carbon. Then we have butanoic acid. So we have oic acid here. So now what I'm doing? See, if you have confusion, I'm expanding this. C double bond O single bond OH. Okay, so this is 3 methyl butanoic acid. So what I'm doing, I'm removing the OH, I'm adding the NH2 group. The compound will be CH3CH single bond, CH3 single bond, CH2 C double bond O. In place of OH, I'm adding NH2. So this is amide. Now, to write the name, what I will do, it will be 3 methyl, same, since we are having the 4 carbon in the main chain, it will be having butane, butanum, Na last. Just you have to remove the oic acid. So butanamide, butane, butan, and amide, amide. So the name will be 3 methyl butanamide. Clear? I'm giving one example. CH3, CH2, C double bond O, single bond NH2. Now do the naming. Okay. I'm making more easy. OH, name is propanoic acid. I'm removing OH, adding NH2, compound will be CH3, CH2, C double bond O single bond NH. Now tell me the name.
Propamide.
Propanoamide.
Propanamide. Very good. The name is propanamide. See, this time you are giving examples, so you are giving the answers. I'm feeling good. What happened in the morning? Yes? What happened in the morning? Okay. Just give examples like this. In the morning also it will be good. Secondary and tertiary amine. Secondary and tertiary amide. Not amine. I don't know why I'm saying amine again. Okay. So in case of tertiary amide or secondary amide, see, we have two type of amides here. So you have to write capital N. You have to write capital N to indicate. You have to add the capital N to indicate the substituent. So the substituent bonded to the nitrogen atom. Okay, so what and substituent present on the nitrogen must be alphabetically arranged. Okay, so don't get confused while writing. If you will not write the name properly and not mention that compound, so it will be quite tough. So see, CH3, CH2, CH2, C double bond O single bond NH single bond CH3. So this is secondary or tertiary? First tell me this thing. See, one chain is this side, one chain is this side with the NH. So this is secondary. Okay. So I'm telling you the first, this name I'm doing and second name you will do. So in this particular case, first I'll write the name of this substituent. And before the naming, I have to add N. So it will be N-methyl. N, then a dash, then methyl. How many four carbons are there? How many 4 carbons are there? And since we are having a amide group, so simply butanamide. So the name will be N-methyl butanamide. I'm giving one more example. CH3, CH2, CH2, C double bond O, single bond NH, single bond CH2, single bond CH3. This is secondary or tertiary?
Tertiary.
Pakka? Confirm? First see again. R is bonded, then secondary. If 2R is directly bonded with this Rn, then it is considered a tertiary. But if you will have a long chain of R over here, but still one H is present, then it is secondary. While in case of tertiary, we have 2R directly bonded with the N. So now see this compound. We have one H here and one long chain is present. So this is again an example of secondary amine. Clear?
Yes, sir.
So now tell me the name.
N-ethyl.
N-ethyl, then
Butanamide.
butanamide. See, don't say it as butane and then amide. Butanamide. Continuous, butanamide. We don't have to give the gap between. Okay. Okay. Let's do example. One more. CH3, CH2, C double bond O, single bond N, then CH2, CH3, then CH2, then CH3. Now tell me this is secondary or tertiary?
Tertiary.
This is tertiary. Why this is tertiary? Because we don't have H. Second thing, we have 2 alkyl group directly bonded with the nitrogen atom. So let's do the naming. how you will do the naming? See, I told you that for each substituent, you have to add the N. So this is ethyl, this is ethyl. So first for N, then you'll make a comma, then again N, one for one ethyl, one for one ethyl, and then di for the two ethyl, then it will be diethyl. And since we have 3 carbon in a chain, so it will be
Propanamide.
propanamide. N and diethyl propanamide. Clear?
Yes, sir.
Yes, sir.
Okay. But what happens when these two groups are different? Then you have to do naming alphabetically. See another example. CS3, CS2, C double bond O, single bond N, then CS3, then CS2, then CS3. Now, this one is named as methyl and this one is named as ethyl. So first, which one should I write?
Ethyl.
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 So N dash
Ethyl.
ethyl. Then
N ethyl.
N
then
methyl.
dash N
N-methyl.
methyl. Very good. And then
Propanamide.
Propanamide.
propanamide. Very good. See, you guys are genius. Just believe on yourself. You guys are genius. Okay. Just have a confidence. See, two things can happen only. Either it will be wrong, either it will be right, or it will be right. Okay. So no one gonna kill you if you'll not answer. And if you'll answer wrong. But at least give it a try. And now you are trying and you are doing good. Okay. So let's take one more example. CS3, CH2, CH2, C double bond O. Then here we have CH2, CH3. Here we have CH2, CH. Okay, where is N? Here. CH2, CH2, and then CH3. Now name it.
Sir.
M-ethanol.
N
M-ethanol. N-propanol.
Ethyl
propanol.
and
Butanamide.
Butanamide, sir.
propyl. Very good. Very nice. Butanamide. Very good. Anethyl and propyl butanamide. So now you got my point of amide.
Yes,
Yes,
sir.
sir.
Yes, sir.
Primary, secondary, tertiary, all clear?
Yes, sir.
Yes, sir.
Okay. Let's move with the nomenclature of cyanides. So this is good that I've got this particular class right now just because we have a huge IUPAC and we need to complete it as soon as possible so that we can concentrate on the next part of the chapter. Okay, so let's do the naming of cyanide. So can anyone tell me what is cyanide? It's C triple bond N. This is called cyanide. So it is highly poisonous compound. And when I was in my school, and I've heard a story about the cyanide that no one can tell the taste of the cyanide. So I don't know whether it is true story or not, but I just want to tell you that when there was a person and he ate that particular cyanide and he was only able to make S. I heard this thing, I'm not sure, but I'm telling you. Okay, so whenever if you teach someone and you learn that, at least you'll remember this thing. So that particular person, when he just tasted this cyanide, I've heard that he just made S. So people were confused, it is salt or it is sugar. So there was a story behind it that no one can tell. Still, there was no one who can tell the taste of this So one person also have to make a contribution to so that he can tell A or U. Okay, so people are like this. I don't know whether it's a true story or a false story, but okay, it's a story. Okay, let's go for the cyanide. CS3C triple bond N. Oh. See, now what you will do, you will write the name of carbon, how many carbons are present, and if single bond is present, then you'll mention the ane. If double bond is present, you'll mention the ene. If triple bond is present, you'll mention the ine. The rest thing for CN, we will use nitrile. What we will use? We will use nitrile. So I'm doing one example, another example you will do. CS3C triple bond N. Two carbons are present. For two carbons, what we use? We use as ethane. And no need to give the gap and continuous right nitrile, ethane nitrile. Easy?
Yes, sir.
And it's quite easy, it's not that much tough. Okay, CS3, CH, then go for CS3, then CH2, 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 then C triple bond N. Now do it. From where should I do the numbering? Just tell me first.
Right answer, sir.
Right
From
side,
right
sir.
side. Let's take 1, 2, 3, 4, 5, and 6. Now tell the name.
5-methyl
5
hexane
methyl. Very
nitrite.
good. 5 methyl.
Hexane, sir.
Hexanitride.
Hexanite
Hex,
nitrate, sir.
hexane. And then nitrile. Very good. Very nice. So it's easy. Okay. It's not that much tough. Okay. Let's move further. Let's do the nomenclature of alkyl halides. These are the quite easiest one, I think. But just remember that every halogen have equal priority, and you will use here the minimum set of locant rule. Remember minimum set of locant? Yes or no? Okay, let's try. First, a basic example. These are also known as haloalkane. Okay. See, alkyl halide is one alkane, alkyl group along with X is there. What is X? Fluorine, chlorine, bromine, iodine. Okay. So, how many of you? Okay, one question. How many of you remember? How if you know the periodic table? Remember the periodic table?
Yes, sir.
Anyone?
Yes, sir.
Full periodic table you have learned. See, if you haven't done this thing yet, two things are there. First thing, you can have mnemonics in the English. Okay. And for that sake, you need to search somewhere. Just because I don't know in English that mnemonics in the English of this periodic table. In Hindi, I know. And if someday, if it is necessary, I'll tell you in the Hindi that thing. Okay. But just because it's a quite easiest way to learn this thing, so just go for the mnemonics and learn it. At least know the position of the elements, know the position of the compounds. Elements and their groups, their periods, and all. So these are also known as 17 group elements. Okay. So alkyl halides. How you'll do the naming? CH3, CH2, CH single bond Br. Then we'll go for the CH3. Okay. What is the name of this compound? You'll do the numbering from the right hand side. 1, 2, 3, 4, 2, bromo. 4 carbon, butane. That's
Butane.
it. It's easy. Okay, let's go for this one. CH3, CH single bond Br, then we'll go for the CH2, then CH, then Cl, then CH3. Just go for it.
Two bromo, four chloro, pentane, sir.
Huh? 2 bromo,
Four chloro,
4 chloro.
yeah, 2
pentane.
bromo, then
Four
4 chloro, 5
pentane.
carbon, then it will be pentane. Very nice. So it is 2 bromo, 4 chloro, pentane. Okay. So now let's make it some complicated. CH3, CH, then Br, then CH, then CH3, then CH2, then CH3. See, one type is 1, 2, 3, 4, 5. Another one is 1, 2, 3, 4, 5. Tell me,
From left hand
red,
side, sir.
red or black?
Black, sir.
Black, sir.
Black. Why?
Sum, sir. 2 plus 3 is 5 and 4 plus 3 is 7.
Very nice. Literally, what's your name?
Vignesh, sir.
Vignesh. Very good. Very good, Vignesh. So that is the minimum set of locant rule. I told you. So what is the name? 2 bromo. We will consider the black one. This red one will be wrong. Okay, 2 bromo. Then 3
Methyl.
methyl pentane.
Pentane, sir.
Very good. See, in the last when I'll complete this particular lecture, I just want to see you all today. Okay, so I just want you to open your camera for that particular time and just want to interact with you. Okay, so one more example I want to take. CH3, CH, then we'll go for the Cl, then CH2, then CH, then single bond CH3, then CH3. Now tell me.
From left side, sir.
From left side?
Yes, sir.
Very good. Again, name 2
2
chloro, 4
4
methyl, yes,
pen
pentane. So these are easy. Just minimum set of locant and that's it. Let's move for the another type, that is ether. Okay, I'll do ether, I'll do amine right now, and I will tell you the priority order today. And I'm expecting one thing. Then when I'll tell you the priority order, you will tell me tomorrow that which functional group must get the priority, because from tomorrow morning we will start a class and we will have a bifunctional groups. It's bi or tri or tetra there can be. Okay, so it means when there is a more number of side chain, more number of functional group, more number of double bond, triple bond, we will add everything now from the next class, from the morning, tomorrow morning 5 a.m. So I'll complete 3 things now: ether, amines, and I'll go for the IUPAC of no, I'll tell you the priority order then. Okay, what is ether? Ether is ROR dash. Okay, ROR, right now I'm writing it ROR. So it is again of 2 type: symmetrical ether and unsymmetrical ether. If I'll go for the symmetrical ether, it means both R is same. Unsymmetrical ether, ROR dash is there. It means one R is different, another R is different. So how you will write the name? First go for the symmetrical one. For symmetrical one, I'm taking one example, CH3, CH2, O, CH2, CH3. So this is the example. Now tell me. No, you don't know, sorry. How can you tell me? I'll tell you. You have to write alkoxyalkane. With one of the side, you will take oxy group, not oxyl, oxy. Okay, with one of the side you will take oxy, another side you will take alkane portion. Since on the either side I'm having same group, CH2, CH3, CH2, CH3. On both sides we have the same group, so we can take with any of the compounds. I'm writing this particular with this one, so there will be no change. The name will be ethoxy and ethane. Ethoxy, ethane. Clear?
Yes, sir.
Okay, one more example. CS3O, CS3.
Methanoxy, methane.
Methane.
Not methanoxy, it's methoxy.
Methoxy, sir.
Methoxy.
Methoxy, methane. Okay, see, okay, not this one. You know what is this? Benzene.
Yes, sir.
Benzene. When benzene come in the side chain, we consider it as at phenyl. Okay. Name will be phenoxybenzene. Okay, so this is just remember this thing. Okay, not a quite big thing. Okay, then go for the unsymmetrical. Okay, CS3, CH2O, CS3. Now what? Now how you will do the naming? Okay, just say the name by your own. Let's try. Let's give it a try. Speak.
Methanoxy, ethane.
Again, you are saying methanoxy. See, N will not be there. It's methoxy.
Methoxy, ethane.
Ethane. See, you have to take O with that side which have lesser number of carbon. So this side having the lesser number of carbon, so its name will be methoxyethane. Very good. So just tell me the name of this compound then. CH3, CH2, CH2, CH. Then we'll go for the CH3, then O, then CH2, then CH3. Now tell me the name.
Sir,
Yes.
ethanoxy pentane.
See, this is ethoxy. Okay, done. This is pentane. This is also done. But you have to mention the position also here. Why? Just because it is not a straight chain. So it is 1, 2, 3, 4, 5. Since this particular 5 chain is bonded with the second atom with oxygen. So you will write 2 here. 2-ethoxypentane. Clear?
Yes, sir.
Okay. Last example of ether. CH3, CH, here CH3, then C, here Br, then Cl, then CH2, then O, then CS3. See the numbering. 1, 2, 3, 4. 2 bromo, then dash. 2
Chloro.
chloro, then dash. 1 methoxy. Methoxy. See, that methyl will be at the end just because it is in the main chain. Okay, so then dash, then 3, then methyl, and then butane. So name is 2 bromo, 2 chloro, 1 methoxy, 3 methyl butane. See, chloro, bromo, fluoro, ido, they will always come in this starting according to alphabetical order. But if in the main chain, side chain is present, then you will add with the parent chain. The name should be added with the parent chain. Okay,
Yes, sir.
let's start with the amines. Okay, so again, these are easy. 1 degree, 2 degree, 3 degree, same rule. N, you have to add N also here with each substituent, and at the end of, like we were doing in amides, here we will add amine. That's it, nothing special. CS3NH2. Tell me the name. Okay, I'm telling the name, then you will do that. Tell the name of another one. Methyl amine. Okay, then CS3N, CS3, CS3. Okay, first tell me, this is tertiary or not? Okay, just leave this example first. Let's first continue with a small example. CH3, CH2, CH2, NH2. Name.
Propenyl amine.
Propane. No, propyl. Propylamine. Propylamine. Very good. Okay, let's take another example. And first I'm telling you 1 degree, then 2 degree, then 3 degree. 1 degree is RNH. One R group is present. So you'll write the name as alkanamine. Okay, you'll use this. The thing what I'm telling you, this one, this is common name, not IUPAC name. This is again, this was common name. So we'll go for the IUPAC now. I was telling you the common name, but we'll go for the IUPAC. For IUPAC, this is alkanamine, then R, N, then R, then 1H. That is called N-alkyl alkanamine. Then R, N, one more R, then one more R, then N, di-alkyl amine. Condition if both R is same. But if another, then N alkyl comma N alkyl alkanamine. If both are different. The two conditions are there. If both R is same, then you'll write N dialkyl alkanamine. If another R is present, then you'll say different R is present, and you'll be N-alkyl alkanamine. Okay, let's do the example. CH3, CH2, 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 NH, single bond, CH3. Vignesh, your name was Vignesh, I think.
Yes, sir.
Okay, tell me, this is 1 degree, 2 degree, 3 degree.
1 degree, sir.
It is 1 degree. Okay, tell me the name then. First, you'll do the naming of substituent. Bhavna, rest. It will take time for me to remember the name. So right now I only know the two names. I'll learn. So this is methyl. N methyl. First you'll write the name of substituent. Then 1. On the first position, we have this compound. Then you'll write, have to mention the 1. Butanamine. 4 carbon. And at the end, you'll write amine. So it will be butanamine. Then CH3, CH2, CH, then NH, then CH2, then CH3, then CH2, CH, single bond, CH3, single bond, CH. This is last example of IUPAC for today. Tell me the name. This is 1 degree, 2 degree, or 3 degree. Yes, anyone? This is 1 degree or 2 degree?
Sir, is it 2 degree?
Yes, it is 2 degree. This is one substituent. Okay, and with N, another substituent is this one. So this is 2 degree. So the name will be N-ethyl. Just because alphabetic order, E will come first. Then dash. In this particular chain, above chain, we have the CH3 is bonded. Okay. So on the fifth position, it is there. Okay, 1, 2, 3, 4, and 5. Fifth position, yeah. So fifth position, that will be 5 methyl, then 3 6 carbon hexanamine. We'll continue this later on also. Now, the main thing. Okay, that is priority order. When I'll complete this, just take a screenshot and remember it. Tomorrow I'll definitely ask in the starting of the class which one is having the more priority, which is having the less priority. First, the highest priority is to the sulfonic acid. The group is SO3H. Then we'll go for the carboxylic acid. The group is COOH. Then we'll go for the anhydride. This is anhydride. First, what is anhydride? COOR, you can say. Okay. No, COR now. COR. R C double bond O single bond O single bond R. Okay. So you can write COR. Yeah. Clear. Then anhydride. Then esters. What was the functional group of ester?
RC double bond O and single bond O and R sub.
See, I've done a mistake over here. This is C double bond O single bond R. Yeah, you were correct. C double bond O single bond O single bond R. And here also R. What I'm writing R C double bond O single bond O single bond C double bond O single bond R. This is anhydride. Okay, then East, after ester we have, so I'm after this I'm writing here. Okay, we have acid chloride. Okay, acid chloride is COCl. Then we have acid amides. That is, acid amide is C double bond O single bond NH2. Then we have nitrile. That is C triple bond N. Then we have aldehyde. That is CHO. Then we have ketone. After this, I'm writing here ketone, that is C double bond O. After ketone, we have thiols. Thiol is SH. Then we have alcohols, that is OH. Then we have alkenes containing the double bond. And then we have alkynes containing the triple bond. Okay, so remaining remaining substituent are treated as substituent, so they are given as the equal priority. Okay, so the carboxylic acid, then carboxylic, then anhydride, then ester, then acid chloride, anhydride, then we'll go for the nitrile, then aldehyde, then ketone, thiol, alcohols, alkene, and alkynes. Clear this much?
Yes, sir.
Yes, sir.
Any doubt? No. Just took a screenshot. Just take a screenshot of this. We'll do example in the next class, and also we'll do the example of cyclic compound in the next class. Then we'll go for the aromatic category, and then IUPAC will be done. So this is my third class, I think. I have taken this 2-hour class on the Sunday, then Monday, then Tuesday. I just took a 2 classes. So 1, 2, 3, 4, 5. 5 classes we have done the IUPAC, and 1, 6 and 7. 2 more classes will be there. The IUPAC will be done. So this week IUPAC will be completed, and you can do the IUPAC of any of the compound in 12th standard also, if you have learned this much. So this one is not that much easy, but it's not impossible. Clear? Clear?
Yes, sir.
So I stop this sharing screen, and I want you guys to open your camera. I just want to see you, who is Vignesh and who is Bhavna and who are others. Okay. So, am I visible? Am I visible?
Yes, sir.
Yes, sir.
See what is mentioned in my t-shirt. Don't quit. So you don't need to quit. You need to do it again and again until you get the success. Okay, I just want to I just want all you to open your camera. How can I see these students? Okay, just 2 people I just want to see right now. Okay, just open your mic also. I'll tell the name. I'll speak the name. Who is Amani? Speak something that I can see. How can a great view? I can see. Okay, now I can see you. Vignesh, I can see you. And Amani, I can see you. Then rest. Some have left the class. Someone left the class. Okay. Gayatri, I can see you. Very nice. Bhavna. Okay. And one more is there. Okay, very nice. This name is quite of Bhaskar. Sriram Bhaskar. Am I correct? Okay. And see, guys, what I want to say is that whatever I teach you in the class, first thing I want to know, are you getting my all points, whatever I'm teaching?
Yes, sir.
You're getting point. Okay. So I just want you to revise everything. And if something happen, like when we are teaching something, any of the teachers teaching, then try to communicate with them. The more you'll communicate, the more you'll ask, the more you'll get the things. Okay. So don't hesitate while speaking. What will happen? What will happen? It will be wrong. It will be right. So I want to hear the voice of every person from the next class. Okay. I only hear the voice of Bhavna. I remember the name Bhavna. Now I remember the name of Vignesh. He's also doing good now. Sometimes Gayatri also speak. Okay. Sriram Bhaskar, I want to hear you also. Just remember. And what is the name? Just say your name.
Ashita.
Ashita.
Ashita. Yes,
Ashrita.
sir.
Yeah. I just want you to speak also. Okay. So next time, speak. You sometime I think I've heard your voice also in the mid.
Yes, sir. Today I said, sir, most of the answers.
Yeah, you've given the answer. So maybe I got confused in the answers of you and Bhavna. There is a
Yes,
possibility. Okay.
Yes, sir.
So next time I'll call the name. I will write the name, and I just want you guys to speak. Okay. Clear? Now
Yes.
give me a thumbs up like this. I just
Okay,
want
sir.
you to study hard and just crack something and let me know. Then I'll come towards you. I'll meet you, and definitely we'll have some party over there. Okay.
Sure, sir.
Okay. Have a good night today. Bye bye.
Bye, sir.
Bye, sir.
Sir, is there any lecture or should I close this? Ma'am, is there any other
Yes,
class?
sir. No, sir. We don't have any class.
Okay.
Yeah.
So I'm
Thank you.
leaving the meeting right now. Okay.
Yes, sir. Okay, sir. Thank you, sir.
Most welcome.
students,
Good night,
again-
everyone.
Yes, sir. Again, we have class tomorrow morning from 5 to 7. Right? And also, please inform your brothers and sisters who are studying 8th and 5th classes about our NMMS and Navodaya free coaching, which is been going through YouTube channel. Okay?
Okay, ma'am.
So, yeah. Yes. Bye, everyone. We will meet tomorrow.